Dynamics memo. Question 1. A fully loaded truck has a mass of 22,000 kilograms and accelerates from rest to a constant velocity of 20 meters per second. Given that air resistance effects are not negligible, the drag force experienced by the truck can be found with this formula. F drag equals kv squared, where k is a constant with a value of 25 and v is the velocity of the truck at any given time. Well, firstly, find the units of k. Well, we know force is kilograms, meters, seconds to the minus 2, and velocity is meters per second. It's velocity squared, so we're going to get meters squared seconds to the minus 2. On the left-hand side, we only have kilograms, and there's no kilograms on the right-hand side, so that stays. And then we've got meters to the 1 and the meters to the 2. Bringing the meters to the 2 over to the other side is going to give us meters to the minus 1. And we've got seconds to the minus 2 on both sides, so they just cancel, leaving us with k having units of kilograms to the 1, meters to the minus 1. Next it says find the value of the driving force of the truck at a constant velocity of 20 meters per second. Well, at a constant velocity, of the driving force and the resistive forces are going to balance out. So if we can find the resistive force, then we know the driving force, which is going to be 25 times 20 times 20, or 10,000 newtons. Given that the percentage uncertainty of the speed of the truck is 3% and the uncertainty in our constant is 2%, find the value of the percentage uncertainty of the driving force. Well, we use k once and v twice, so it's going to be the percentage uncertainty of k plus the percentage uncertainty of v twice. So 2 plus 3 plus 3 is 8%. And then state the value of the driving force with the absolute uncertainty below. Well, it's going to be, what's 8% of 10,000 is 800, and that's already to one digit, so 10,000 plus or minus 800 newtons. Next, we've got define linear momentum. Well, it's the product of mass and velocity. And what's the momentum of the truck at a speed of 20 meters per second? Well, it's mass times velocity, so 22,000 times 20, we get 440,000 kilogram meters per second. Next up, define force. Well, force is equal to the rate of change of momentum. As the truck approaches a stop sign, the driver of the truck applies the brakes, disengages the engine and slows the truck to rest over a period of 100 seconds. Ignoring the effects of air resistance, find the braking force. Well, we already know force is equal to the change in momentum over the change in time. Well, we need to remove all that momentum and end up with no momentum. So we actually have to remove 144,000 kilogram meters per second, and divide that by our time of 100 seconds, we get our force of minus 4,400 newtons. Number 2, a tennis ball of mass 50 grams moves towards a tennis player with a speed of 6 meters per second. The tennis player strikes the ball with a force of 8 newtons and a duration of 100 milliseconds. In the other direction, what's the final speed of the tennis ball? Well, again, we know force is equal to the change in momentum over the change in time. So force times time, or the change in time, is the change in momentum. Okay, so the change in momentum, well, as the ball is going in one direction and the tennis player is striking it in the other direction, well, we're going to say that the force is negative. So minus 8 times 0.1 is minus 0.8 kilogram meters per second. From GCSE, actually, the force times time is mv minus mu, and we put all our values in, and we only want to find out what is v. Rearranging just to get make v the subject, we actually find the final velocity is minus 10 meters per second. So the ball is now going in the opposite direction with more velocity. Okay, number 3, during a physics demonstration aboard the International Space Station, an astronaut blows 25 grams of water at 2 meters per second horizontally, while another astronaut blows 50 grams of water vertically with a speed of 3 meters per second. Given that the ball of water meets and merge, what's the final velocity of the ball of water? Horizontally, let's think about what's going to happen with the momentum. So we want to find the horizontal and vertical momentum separately. Then we can use Pythagoras and trigonometry to find the final angle. So horizontally, We've got our mass times velocity, so 0.025 times 20, times by 2, we get 0.05 kilogram meters per second. Vertically, 0.05 times 3, we get 0.15 kilogram meters per second. The two momentum vectors are at 90 degrees, so we can actually use Pythagoras to work out what's the final momentum vector, or the magnitude of the final momentum vector. We get 0.158 kilogram meters per second. The angle to the horizontal, we're going to use tan. So tan to the -1 of the opposite over the adjacent, and we get 71.6, or basically 72 degrees. We need to know the final velocity. Momentum is mass times velocity, so we're going to divide by the total mass of both of our balls of water. So 0.158 divided by the total mass, 75 grams, 0.075 kilograms, we get 2.1 meters per second and an angle of 72 degrees to the horizontal. And finally, number 4, water leaves a garden hose pipe horizontally at a speed of 30 meters per second. Given that the density of water is 1,000 kilograms per meters cubed, and the pipe has a cross-sectional area of 0.5 centimeters squared, find the recoil force experienced by a person holding the pipe. Well, F equals change in momentum over change in time. What's the total mass leaving the pipe every single second? Well, mass is density times volume, but we don't know the volume, but we can calculate it because it's going to be the cross-sectional area times by the speed. If you think every single second, 30 meters of water is streaming out from our pipe. So, first thing you need to be careful of is the cross-sectional area we know is 0.5 centimeters squared, so we need to convert that into meters squared. So we've got 1.5 times 10 to the -3 times by 1,000. We've got 5 times 10 to the -5 times by 30. We got 1.5 times 10 to the -3 meters cubed. Then the mass is going to be 1.5 times 10 to the -3 times by 1,000. The density of water, we got 1.5 kilograms leaving the hose every single second. So finally, force is change in momentum over change in time. So the momentum being transferred is 1.5 times by 30, okay, and that all happens in a period of 1 second. So the force that the person holding the hose will experience is 45 newtons.